Subscribe now and press the bell icon. Never miss an update.
Welcome back to the channel. In our last video, we explored how to perform a stiffness irregularity check using ETABS 2016. Today, we're taking it a step further and comparing the results from ETABS version 9.7.4 with ETABS 2016 to see if there's any difference in the outcomes. This is crucial for anyone working on structural designs to ensure accuracy and compliance with modern codes. Let's dive into the details and find out how both versions perform. As many of you already know, a soft story refers to a floor in a building that has significantly lower stiffness than the other floors. But just to refresh your memory, let's quickly review what it is and why it matters. Soft stories are common in multi-story buildings due to architectural or occupancy requirements, like large open spaces or parking garages. Essentially, a soft story, or flexible story, presents a weak point in the structure. This lack of stiffness can lead to local or even total building collapse during seismic events, putting lives at serious risk. While it's best to avoid soft stories, if one exists in your design, a dynamic analysis according to the UBC code is absolutely necessary to ensure safety. Now, let's dive into ETABS version 9.7.4 and see how we can identify stiffness irregularity. First, we'll analyze the structure to get the results we need. After running the analysis, pay close attention to how we extract the data. We'll start with the story shear table for the EQX load case. Once you have that, copy it into a new Excel file. You'll need to remove any stories that don't require checking for soft story irregularities, like those for overhead water tanks, machine rooms. Next, you'll see the top and bottom location results in the story shear data, but we only need the bottom location, so let's clean up those rows. Now we'll take the VX column, representing the story shear for the EQX load case, and paste it into the Excel sheet I've prepared specifically for checking stiffness irregularity in ETABS 9.7.4. We're using UBC code table 16-L, which you're already familiar with if you've seen my previous video. Any unused stories should be filled with 0 values based on the project's story limits. I'll also show you how to copy the story names from the ETABS 9.7.4 table into the Excel sheet to make everything more organized and presentable. Now, we'll repeat the same process for the EQY load case to check the shear in the Y direction. Now, we need the story average displacement values in both X and Y directions for these load cases. Follow along as I extract the displacement data. To do that, go to the File menu, select Print Table, and then click on Summary Report. Navigate to Story Maximum and Average Lateral Displacement. This table contains data for maximum displacement, average displacement, and the ratio between them. However, for our calculation, we only need the average displacement at this point. And manually input the values into the Excel sheet. The sheet is already set up with formulas, so once you input the data for both the story shear and displacement, it will automatically calculate the drift, stiffness, and stiffness ratios. Story drift is calculated as the difference between the average displacement of a story and the average displacement of the story directly below it. You can see the formula on the screen. Next, the story stiffness is determined by taking the ratio of the story shear to the story drift, and that formula is also displayed on the screen. We're looking to confirm that the stiffness ratio meets the UBC code requirements. The ratio of the story stiffness to the stiffness of the story above should not be less than 0.7, and the ratio of the story stiffness to the average stiffness of the 3 stories above should not be less than 0.8. As you can see, the ratio of story stiffness to the stiffness of the story above is not less than 0.7, which indicates there's no soft story based on this check. This column in the Excel sheet calculates the average stiffness of the 3 stories above, and one of the calculations is shown on screen. The 8th column calculates the ratio of the story stiffness to the average stiffness of the 3 stories above. Since none of the values are less than 0.8, it confirms there's no soft story according to this check as well. You'll see the final results in the Excel sheet, which will indicate whether each story is regular or soft. In this case, the results show no soft story in either the X or Y direction. Now, let's move on to ETABS 2016 and perform the same check for stiffness irregularity. The process starts the same way. We analyze the structure and extract the story stiffness data for the EQX and EQY load cases. Once the analysis is complete, go to the Display option, then click on Show Tables. From there, follow along as I walk you through the steps to extract the story stiffness results. One key difference between the two versions is that in ETABS 9.7.4, you have to manually calculate the story stiffness, whereas in ETABS 2016, the software provides a direct table for story stiffness, making the process much more efficient. Even though the calculation steps remain the same, the time-saving aspect in ETABS 2016 is significant. The remaining steps were already covered in my previous video on stiffness irregularity checks using ETABS 2016 and an Excel sheet. You can refer to that video for a detailed step-by-step walkthrough of the procedure. In the end, you'll see that both versions give the same result. This building has regular stories with no soft story in either direction. This comparison highlights how newer versions of ETABS streamline the process, though ETABS 9.7.4 is still widely used, especially in offices in Pakistan. If you need the Excel files I used to check stiffness irregularity in ETABS 9.7.4 or ETABS 2016, just contact me through the email address provided in the description. Thanks for watching. I hope you found this comparison helpful. Don't forget to like this video if you did, share it with fellow engineers, and hit the subscribe button for more insights on structural design processes. And remember, if you're looking for professional structural design services, whether it's for your dream residential house or complex structural steel design for industrial projects, I'm here to help. Feel free to reach out anytime. See you in the next video.